question. Which of the following oxides is basic in nature? Which of the following oxides is basic? Okay. How did you to identify the basic means? It's very simple. Find out the oxidation state. Here 4 option is given. Among this, which one is the lowest oxidation number? Has more basic nature. Okay children, this is a concept. So now to find out the oxidation number. Okay, so here Mn2, first option A, Mn2O3. So 2x minus 6, 3 2s are 6. Okay, so 2x equal to 6. X is equal to 6 by 2 equal to 3. Okay, so next option B, x minus 2. So x is equal to plus 2. Next here Mn2. Option C, x. Okay, x here minus 4 equal to 0. So x equal to plus 4. Okay, so next D, 2x. 7 2s are 14. Minus 14 equal to 0. So 2x equal to 14. X equal to 14 by 2 equal to 7. Okay, so now to find out the oxidation number. Option A 3, here 2, here 4, here 7. So which one is the lowest oxidation number? Option B. So this one has more basic in nature. Children, basic in nature means for this substance now to added in the water to convert it into hydroxide formation. That is denoted as the basic in nature. Are you clear children? Okay, so here according to the concept, the lowest oxidation state has more basic in nature. Identify the transition element. Here the electronic configuration is given. Okay, so don't calculate one by one children. To easy way to find out, use the general electronic configuration of D block. What is the general electronic configuration of D block? N minus 1, D 1 to 10, Ns2. Okay children, based on this, now to identify. See the outer valence electron. Here 3s2, 3p, 4s. No D orbital. So just leave it. Next here, last one p orbital. That also leave it. Okay. See here also p orbital. See the outer valence electron. Okay. So here p orbital. That also leave it. So what about the remaining? Here 3d2, 4s2. See the outer valence electron. Okay. ns2, 4s2. Next n value now here 4. So 4 minus 1, 3. 3D 1 to 10, but here 2. So which one is the correct option? Option C. Can you guess it children? I hope you can understand this very easy way. Now to use the general electronic configuration and to identify. Okay, because the outer valence electron, if S orbital means S block element, P orbital B block element, D orbital D block element, F orbital F block element. So keep in your mind the general electronic configuration. So easily you can find out the whatever the question they are asking, you can answer it very that quickly. Okay children. Next question, Mond process is used for. Okay, here nickel, aluminium, iron, copper is given. Okay, so this lessons, this topic in the first lesson children, Mond process, zone refining process. Okay, so now you can answer it as very easy way. So you know the answer. Okay, so in nickel extraction we use the Mond process. Mond process means nothing but nickel react with carbonyl group. Okay, now to form nickel tetracarbonyl. Again this tetracarbonyl to use pure nickel as well as carbon monoxide. This is the volatile substances. Okay, is evaporated. So now to get the pure nickel. So now what is the correct option? Option A, nickel. Next question, most stable stability. Okay, stable oxidation state of iron is, okay, iron element is iron. Okay, atomic number 26, electronic configuration 3d6 4s2. Okay, so now first option A, Fe plus 2. This 2 electron it is lost. Okay, so Fe, what about the oxidation state? Plus 3d6. Okay, 3d6. Fe plus 3. So 2 and 1. 3 electron it is lost. So remaining 3d5. Next minus 2. Gain 2 electron. Okay, so 3d8. 4s2. Next minus 3. So minus 3 gain 3 electrons. Okay, so option D, 3d 3 electron it is gained. Okay, 3d9 4s2. Okay, but here due to symmetry electron it is transferred. So 3d10 4s1. Okay children, so stable. Here 3d5 as well as here 3d10. Okay, so now among this again have the competition. So which among this is more stable is the half filled one. Okay, so plus 3 state it is more stable oxidation state. Children, again maybe you have doubt, mean refer the 11th standard book in second lesson, last topic, stability. Okay, because they are explaining in half filled configuration exchanges energy is, number of exchange energy is more than the partially filled as well as the completely filled. Okay, so here now the pairing takes place. Okay, during this exchange of electron, pairing started. So 3d5 is the more stable. So correct option is B. Next question, which of the following complexes is an outer orbital complex? Okay, what is meant by outer orbital complexes? Means the electron enter in within the d orbitals is known as inner orbital. Maybe if d orbital is completely filled, now to starting from s orbital or p orbital, mean that denoted as outer orbital. Okay children. So now first to find out the oxidation state, one by one want to calculate. Okay, so CO, cobalt, find out the oxidation state. Here NH3 neutral ligand. So cobalt oxidation state 3. Next, okay, so first take the A, option A. Okay, we see the step by step. So here X, cobalt plus 3 oxidation state. Cobalt atomic number 27. Okay, 27. So 3d7 4s2. Okay, here plus 3. So 2 plus 1, 3 electron it is lost. So 3d6 electronic configuration. Okay, so here draw the d orbital. 6 electron. Okay, 1, 2, 3, 4, 5. 6 electron. 1, 2, 3, 4, 5, 6. Okay children, so now this NH3 is a strong ligand. Cn also strong ligand, NH3 also strong ligand. So start pairing. So start pairing means it look like that. Okay, so already this one pairing. So this electron is shifted here. This electron is shifted here. That's all. Now from this NH3 ligand entered here. Okay, so D2. Next, 1 s orbital, 3 p orbital. Okay, so NH3 ligand, NH3 electrons. So now what about the hybridization? D2 sp3 hybridization. Okay, so now electron enter in d orbital. So the CO option A is the inner orbital because electron enter in d orbital. So same way for to find out the remaining also children. Okay, Magnus atomic number 25. So 3d5 4s2. First find out the oxidation state. x, consider as x, minus 6, here minus 4, so 2. Okay, so Mn plus 2. Mn plus 2 means last this 2 electrons, so remaining 3d5. Okay, so d orbital 5 electrons, 2, 3, 4 and 5 electron. Here cyanide is the strong ligand, so start pairing. So now is look like that, so start pairing. Okay, remaining 2 empty shell. So the cyanide ligand enter here. Okay, so 1, 2, 3, 4, 5, 6. So totally what about the hybridization? Again D2sp3 hybridization, electron enter in d orbital. So this also is denoted as inner orbital complex. Next take the iron. Iron atomic number 26. So 3d6 4s2. Now to find out the oxidation state, same way. Okay, so here minus 6, 4, so plus 2, Fe plus 2. Fe plus 2 means here this last, so 3d6. Same way for d2sp3, so inner orbital complexes. In NiNH4, nickel atomic number 28, so 3d8 4s2. Okay children, here nickel plus 2 because this one neutral ligand, so remaining 3d8. Okay, so 3d orbital 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5, 6, 7 and 8. One correction in the question, here have no oxidation state. Okay, that denoted as neutral complex. So nickel 3d8 4s2. Okay, so 3d8 4s2, 2 electron. So now this one start pairing. At the same time from the 4s the electron shifted here. Okay, so write again 2, 4, 6, 8. Okay, 1, 2, 3, 4. Next fifth one. This electron shifted here. So now 4s orbital is empty. Here ligand is 6 times. Okay, so now NH3 ligand electron enter here from the s orbital, not in d orbital children, outer. So now electron enter from s orbital. So next p3. Okay, here p orbital 3. So 2 third. Next d orbital here as well as here. So what about the hybridization here? Yes, P3 T2. So totally 3 plus 2 5, 5 plus 1 6. Are you clear children? So now at the same time electron enter from the s orbital. So outer orbital complex. So among this which one is the correct option? Option D. Children, I hope you can understand this. Inner means electron enter from the d orbital, that denoted as inner. Outer mean from s or from p whatever, but not in d orbital. So such a type of electron is entered as a inner as well as outer. So this one on to you must work out based on now VB theory. Based on this VB theory we applied and find out the answer. Next question, which one of the following compound is not colored? Children, previous question, that is the same pattern we work out, but the complex is totally different. Okay, if you see this complex, you feel it's difficult. Okay children, so I take this question and solve now. So how to work out is very easy. Mean first to split cation, simple cation as well as complex anion. Okay, so now take the first one, Na2CuCl4, Na2CuCl4. So put the box. This one simple cation, complex anion. Here Na2, so 2 plus. So this one 2 minus. So now to find out the oxidation state. Okay, so CuCl4 2 minus. Find out the oxidation state. So copper X minus 4 equal to minus 2. So plus 4 minus 2. So plus 2. X is equal to plus 2. Okay. Copper atomic number. Write the atomic number 3d9 4s2. Here plus 2. So last 2 electrons. So remaining 3d according to the concept symmetrical. So 3d10 4s1. So remaining 3d8. Okay. So here 3d8. Okay. So next Na2CdI4. Same way for to find CdI4. Okay. 2 minus because sodium 2. Cadmium. Cadmium is present below the zinc. Zinc outer valence electron is an easy way trick, children. Okay. Zinc, cadmium, mercury present in the periodic table. Now cadmium oxidation state want to write. Here 3d10 4s2. So automatically this one for 4d10 5s2. Okay. So now to find out the oxidation state. So X here 4 minus 4 minus 2. So X is equal to plus 2. So plus 2 means what about the remaining 3d10. Okay. So next one Fe. So this also FeCN6. Here 4. So 4 minus FeCN6 4 minus. Find out the oxidation state. Here minus 6 4. So plus 2. Fe plus 2. Iron atomic number 26. So 3d6 4s2. So 2 electron it is last. So remaining 3d6. Okay. So last one K3 FeCN6. Here 3 minus. So 3 minus means the oxidation state is 3. Okay. So 3 means here 2 plus 1 3. So remaining 3d5. Okay. So in option D 3d5. Okay. So now to find out which one has the no unpaired electron, 0 or D10. The compound is not colored. So here how many unpaired electron? 3 unpaired electron. Here 3D10. So now Na2CdI4 is the correct option because D orbital 0 or 10 the compound is not colored. So remaining here D6. So here number of unpaired electron 4. Here number of unpaired electron 5. So here no unpaired electron. D orbital 10 electrons. So this compound is not colored. This is a final question. The transition element with the lowest atomic number is, okay, AS block. The first element is hydrogen. Okay, children. In D block, transition elements, the first element is, you know, see here, scandium. Okay, next yttrium, lanthanum, actinium. This one atomic number 21. Okay, atomic number 39. Atomic number 57. Actinium atomic number 89. Okay, children. So this is the starting element for D block element, transition elements. In B block, the starting element is boron. Okay, atomic number 5, 1s2, 2s2, 2p1, starting element. Are you clear, children? So in D block, the first element is scandium. You know, for each row 10 element is present. Okay, scandium, titanium, vanadium, chromium, manganese. Okay, so this is the starting element. So see the option: scandium, titanium, zinc and lanthanum. So the correct option is scandium. Children, I hope this sessions you can understand is very well. Thank you, children.